Hello everyone, we are Group 6 from Class AI66B, and today we are honored to present our project titled Student Information Management System using Database Normalization and GUI Integration. Our team consists of three members, Vũ Văn Tuệ, Phạm Huy Thành, and Lê Dịch Quyền. Together, we collaborated to build a fully functional academic information system grounded in relational database theory and practical software engineering principles. Let me begin with a brief overview of our project. In this work, we designed and implemented a complete full-stack relational database system for managing academic information. To ensure data quality and minimize redundancy, we transformed the initial raw dataset through a rigorous normalization pilot, reaching third normal form 3NF and securing referential integrity throughout the schema. Based on this foundation, we developed a comprehensive entity relationship diagram and an optimized logical design covering students, lectures, subjects, classes, and enrollments. On the implementation side, we built a modular Python backend using clean architecture principle, parameterized SQL, and strict enforcement of business rules, such as preventing duplicate enrollments. To support end user, we created a user-friendly GUI that enables intuitive CRUD operation for all major entities. Beyond basic operation, we also integrated analytical features, including dashboards, KPIs, and SQL-driven insight to support academic decision-making. Overall, the system achieved strong data consistency, secure and reliable operation, and noticeably improved performance across the platform. Let's begin with the introduction. Now, moving on to the problem context. In many academic institutions, data is initially collected in anomalized or semi-structured formats. A single record may contain multiple entities, attributes may be non-atomic, and some fields may include repeating groups. These structural issues lead to a series of classic data integrity problems, including redundancy, insertion anomalies, update anomalies, and deletion anomalies. As a result, the system becomes harder to maintain, query becomes slower, and the reliability of stored information is significantly reduced. To address these challenges, it is essential to build a rigorously normalized database. Ideally, through third normal form, achieving 3NF ensures logical consistency, minimize redundancy, and provide the foundation of stable and efficient query performance. Therefore, our project focuses on systematically transforming the data set from UNF to 3NF using functional dependencies and structural decomposition to produce a clean, reliable, and scalable database design. Next, let me briefly summarize the scope of our project. First, we performed a full normalization workflow from UNF to 3NF, guided by formally derived functional dependency. Second, we designed the complete relational schema, including primary keys, foreign keys, constant, and cardinality rules, and mapped it from the ERD into the final database structure. Third, we implemented a modular Python backend using MySQL connector with clean separation between model, service, and the connection layers. Fourth, we developed a user-friendly GUI that supports intuitive CRUD operation for student lectures, subjects, classes, and enrollments. Fifth, we added analytical features such as SQL Insight, dashboard, and KPIs for academic decision making. Finally, we evaluate the system performance, consistency, and error handling, and suggested improvement for future work. Overall, the project delivers a complete end-to-end student information management system built on solid theoretical and practical foundation.
Hi, my name is Huy Thanh, and I'm gonna present the content from slide 8 to slide 19. First, in academic data systems, poor database design often leads to redundancy, inconsistencies, and update anomalies. To address these issues, normalization is widely used to ensure data accuracy and consistency across the system. Normalization is based on EF code relational model It transforms raw UNF data into structured relations and uses functional dependencies to validate and guide decomposition. This reduces redundancy, prevents anomalies, and improves query performance. In this project, our focus is to normalize data up to third normal form. 3NF offers a clean, logical, and efficient structure suitable for real-world implementation. Our data is organized as relations, tables with tuples and attributes. Primary keys ensure unique identification, while foreign keys maintain referential integrity. These constraints prevent duplication of records and inconsistent updates, creating a stable foundation for SQL operations. To enhance usability, we implemented a graphical user interface, so users don't need to write SQL manually. The GUI supports full CRUD operations for students, lecturers, subjects, classes, and enrollments. This improves accessibility, reduces user errors, and demonstrates the practicality of the system. At the slide 13 and 14, we begin is the methodology and normalization process. Uh, we begin with UNF data identifying repeating groups, multi-value attributes, and common anomalies. Then we establish the full set of functional dependencies and decompose relations step by step according to normalization principles. Then at the normalization steps, at first at UNF to 1NF, we remove repeating groups and ensure atomic values. At 1NF to 2NF, we remove partial dependency. At 2NF to 3NF, we remove sensitive dependencies. This results in a cleaner, well-structured database schema. After normalization, our relations are consolidated into the final ERD. It captures entities, attributes, keys, and relationships accurately. And this is the final ERD of our group. Our system has three layers. The presentation layer handles the GUI, the application logic layer applies business rules and validation, the data layer handles SQL execution, schema creation, and sample data through schema.sql and seed.sql. Our flow includes GUI-based CRUD modules with input validation, clear exception handling, optimized SQL queries, and searching and filtering features. We also provide analytics and dashboard visualizations for academic insights.
Hello everybody, my name is Lizzie Gwen and today I'm going to present you our project Student Management System. Here you can see is a dashboard with real-time KPI. Our system have 202 students with 6 subjects, 4 classes, and the average grade is 4.74. On the right side, you can see here is the top 10 students ranked from highest to lowest, and on the right, on the other side is the grade distribution. Moving up here, we have a student management system. Here you can see is a table with students info, which is ID, first name, last name, and so on. And here you can edit it and delete it, and also add a new student that you want to. Coming up next is the subject part and the lecture part, which show us the subject that we teach and the lecture we have. Besides is the classes, which will show us the subject and who teaches that subject. Finally is the enrollment, which will give us the information about the classes that students have applied for. Our system have completed 4 queries. The first one is the student grade by inner join, which is show the student who have grades. Secondly is the left join, which show us all the students and ensure that students without enrollments are also included. Thirdly is the complete enrollment info, which will contain the which will join student enrollment classes, subjects, and lecture info into one table. And finally is the student above global average, which will show us the information of student whose average grade exceeds the overall of all students. And in here you can change the number of classes here to see how the number of mean classes will affect the ranking of the students. And besides, here we have the export CSV button, where you can click it and export the information for yourself, so you can come home and see it later. It will apply also for the subject, the lecture, the classes, enrollment, inner join, left join, multi-table, and finally is the above average. Through this lesson, I've learned how to normalize decision effect, define MySQL scheme, having better understanding about how HDR design guides the table structure and for each key, and understand how GUI workflow depend on having a clean, well-organized scheme, and know how to improve coordination while connecting Python code with SQL queries, and became more confident using GitHub to manage database and code update. For my future work, I'm gonna learn how to add a secondary index and optimize the queries to improve the overall performance of my subject. Besides, I will use the sort procedure or trigger to automate the routine database test. Furthermore, I will learn how to develop a full test suite to improve the stability and reliability of my project. And finally, I will enhance the GUI to make the system easier to use and more accessible for everybody. That's all about my subject. Thank you for listening.